So basically, I'm in charge for your class for the subject Principles of Electrical and Electronics, code BEKG 1123. Okay. So this subject is basically one of the subject yang awak boleh transfer credit. So for those yang layak, yang daripada diploma dan layak untuk transfer credit, so I hope awak boleh apply lah untuk to try and mohon for the transfer credit exemption for this subject. Okay, so before that, boleh saya tahu this section ni majority from diploma or matric?
Saya diploma.
Diploma. Kebanyakan diploma ke?
Diploma, doktor.
Okay, so suppose awak dah ada basic. Okay. So ada from diploma, ada from matrix. So suppose yang from diploma, I think you have the basic knowledge of electrical and electronics. Okay, so because this subject ni especially for UTEM diploma students, so these subjects I think most of the content is quite similar to the diploma, but with an additional chapters. Okay. So before we start with our lecture, I would like to explain on the subject implementation. Okay. So if you look at here on the, can you see the screen right now? You can see my screen, right? Stop record.
Boleh.
Okay. Ada yang dah record ya? Okay, so this is the ULearn for BKG 1123. So I've already uploaded the slide and tutorial for week 1. Okay, so you can go to your ULearn. So basically over here in the general info section, I've listed out the meeting platform that I'll be using. So the first one is Telegram group. Okay, so any last minute announcement, for example, class cancellation and so on, I will the fastest platform that untuk saya sampaikan that information is through Telegram group. Okay, so make sure that all of you already join the Telegram group for 1 BEKG session 3. Don't join yang 2 BMCG punya. And for the synchronous lecture, online lecture, we will use Microsoft Teams. And for the notes, the tutorials, quizzes, midterm tests, we will use ULearn. Okay. And lastly is the recorded lecture. This one is actually because in the previous semester, I uploaded the recorded lecture in YouTube. But this semester, I'm not sure yet whether I will upload it inside the YouTube, because last year I used WebEx, but this semester I use Microsoft Teams. So in Microsoft Teams, you can directly get the recorded lecture. Okay. So next, these are the learning outcomes for this subject. So it's basically the objective that you need to achieve at the end of the semester for this subject. So we have listed out 3 learning outcomes. So this is basically, this is also a self-assessment. So you need, at the end of the semester, you need to ask yourself whether you already able to explain the basic principles of electrical and electronics components, terminologies, configuration laws, and also rules. And ask yourself whether you're able to apply appropriate circuit analysis methods to solve DC circuit problem. And lastly, whether you're able to analyze circuits containing semiconductor devices. Okay, and this is the synopsis. You can read it by yourself. Okay. So this one is the introduction about myself. This is my name, Izrin Farina. So I've been with UTEM since 2011. So it's been 9 years already, minus 3 years. I'm doing my PhD. So basically my bachelor degree and my master's degree from UTM Skudai. My bachelor degree is actually majoring in control. My master's is in mechatronics and my PhD is in electronics. So three different majoring, but actually is interrelated to each other. Okay, and over here you can see my email, izrin@utem.edu.my, and my handphone number. So I think the best medium to contact me is through WhatsApp or Telegram lah. Okay. And over here I already uploaded the teaching plan. Okay, so teaching plan is very important for every subject. Okay, in the teaching plan we have the learning outcomes that I explained previously, the synopsis. Okay, and these are the references that you can refer. We have 7 references. We have listed out 7 references, but the main one that I think most university students use, not just in Malaysia but also overseas, they use this the first reference, which is the Fundamentals of Electric Circuits, okay, by Sadiku. So this is basically the same book that I used more than 10 years ago. Okay, the same book by Sadiku, Fundamentals of Electric Circuits, but different edition. So now it's already the 6th edition, okay, 2016. So if you want to buy books, for example, to refer, so this is a very good books that you can buy. Okay, so because you use it not just for these subjects, but also you can use it for other subjects, for electrical engineering subjects, other electrical engineering subjects. Okay, and next is the course implementation. We will have a 3-hour lecture per week. So the first class on today, Thursday, okay, is a 2-hour lecture, and then we have another 1-hour lecture on Friday. Okay, and tutorial 1 hour on Friday. Okay, but the tutorial session is not every week. It depends. Maybe 5 weeks per semester. Okay, but my apa yang saya selalu jalankan adalah for example, if I manage to finish the syllabus for that week in the first session, then we will not have the second session on Friday. Okay, but if I did not manage to finish the week syllabus, the syllabus for that week, then we need to have another class on Friday. Okay, so this is the course evaluations. Okay, we will assess you in terms of assignments, quizzes, midterm tests, and also final exam. Okay, so for the assignment, we will have 1 quiz. Okay, this is I think it's a group assignment. Okay, group assignment, 15%, and it will cover LO3. So if you refer back to the previous 1 year, LO3. So what is LO3? Analyze circuits containing semiconductor devices. Okay, so you need to expect that your assignment, okay, melibatkan analisis circuits containing semiconductor devices. Okay, ia akan melibatkan electronics punya part. So this subject is actually combination of electrical and electronics. So the first part is electrical, the second part maybe after the midterm break is the electronics part. Okay, so you need to expect that your assignment will be tested based on the electronics part. And then we'll have quizzes, 2 quiz, 1 quiz 2.5, another quiz is 2.5%. Okay, so we'll test LO2 and also LO3. So you refer here what is LO2 and also LO3. And midterm test, we'll have one midterm test, 20%. Okay, so we'll cover in terms of LO2 and also LO3 too. And lastly, we'll have a final examination. 4 questions. We'll test LO1, LO3, LO2 and also LO3. So total is 100%. Okay, so next is the syllabus and delivery planning. So if you look at here, so now since due to the COVID-19, the delivery method now is online, 100% online. Okay, so if you refer here, for example, week 1, which is this week, I will cover chapter 1. Okay, I will finish chapter 1 and then we'll have the tutorial over here. Okay, next week, then we continue with chapter 2. Okay, so you can refer to the syllabus planning. Okay. Okay, so if you refer to week 1, so this is the learning outcome for chapter 1 actually. Okay, we have 5 learning outcomes for chapter 1. Okay, so for chapter 1, you must ask yourself at the end of chapter 1, you must able to describe the basic electrical system and the concept of electrical charge and so on until you'll be able to identify the circuit elements. Okay, so if you look at in week 1, these are all the slide presentation for week 1. Okay, so we have 3 slides, chapter 0, chapter 1 and part 1, chapter 1, part 2. Basically, actually, I divide part 1 and part 2 is for session 1 and session 2 for Thursday and Friday. But like I said before, if I manage to finish both part 1 and part 2 on Thursday, meaning today, then we don't need to have class on Friday. Okay, so this one is very important. Please take note that every week you need to submit a weekly summary and also any comments or feedback regarding the lecture. Okay, so make sure that you leave the summary, leave comments on the correct link. For you is 1 BEKG section 3. Okay, so this is for FKM students. Okay, so your attendance, I will refer to here. Okay, I will actually take your attendance weekly based on the weekly summary. So if you buat weekly summary, then so awak dikira datang lah. If not, no attendance for that week. So make sure that you remember to buat weekly summary and tulislah dekat sini Yulen ni. Okay, and this week because we managed to finish 1 chapter, then we'll have a tutorial 1. Okay, and you need to do your tutorial 1 and submit in the respective link. Okay. Okay. Okay, so this is your lecture session. Okay, the lecture is Thursday or Friday. For mechanical students and manufacturing students, their classes is on Tuesday and Thursday. So because you're majority of you is from diploma, electrical engineering diploma, so I think this subject is maybe quite easy for you, okay, compared to this student, BMCG student from mechanical and manufacturing faculty. Okay. So in the slide you ada beberapa wordings that you can baca lah, okay, that you can use throughout your studies because you're a first year students yang awak boleh guna pakai throughout your studies 4 years in UTEM. Okay, so if I'm sure that you guys have your own dreams, what you want to achieve. Okay, but dreams is just a dreams without dedication, responsibility, education, attitude, and also motivation. So all of these are very important. If you have the knowledge but you don't have the attitude, pun tak elok. Okay. So this is the class policy. Basically, this is for face-to-face class, but some of this can also be used for online class. For example, be punctual to lecture and tutorial. Pay attention. So even though this is online class, I want you to pay attention, take notes when necessary. So if I ask questions, please respond. Please have a two-way communication during lecture. Okay, if get bored or sleepy, you can wash your face and submit your assignment any task given on time. Okay, attire properly ni is for face-to-face class. Okay, so this is actually about OBE. I don't think I want to explain further about OBE because I think maybe other lecturer already explained this. Okay, because this is not your first class for this week, right? So I hope that other lecturers already explained on OBE. Okay. So and this is the last slide. Okay, yang boleh refer 8 adab belajar. And the subject material, I put it in the ULEARN BEKG 1123 Principles of Electrical Electronics. Lecturer, make sure that awak masuk lecturer yang betul ya. Because for this subject, for this semester kita ada banyak lecturer because this subject diambil oleh beberapa fakulti. We have FKKK, we have FKP, we have FKM. Okay, so make sure awak masuk pada ULEARN yang betul. Okay. So, without wasting time, we'll start with chapter 1. Okay, so chapter 1 is basically introduction to principles of electrical and electronics. Let's check. Okay, so these are the subchapters. In chapter 1, we have 9 subchapters. Okay, very short, actually quite short subchapters. Sekejap, weekly summary. Okay, so ada yang tanya weekly summary cerita tentang apa? So weekly summary is saya nak awak summarize apa yang awak belajar for that week. Okay. Short summary, bukan long summary, short summary apa yang awak belajar for that week. And also if you have any comments or feedback, okay, so awak boleh tulis juga dekat situ. Okay, so ada soalan lagi? Kalau tak ada, kita proceed. Okay, so for chapter 1 we have 9 subchapters. Okay, short subchapters. The first one basic electric system, and last one is circuit elements and passive and active. And these are the chapter outcomes. Okay, at the end of this chapter, students should be able to describe basic electrical system and concept of electrical charge. Differentiate between EMF and potential difference, understand system of units, describe electrical measurement instruments and the symbols of electrical sources and components, and identify the circuit elements. Okay, so the first one here is basic electric system. So when we talk about electric system, it's actually where we deals with communication and transfer energy from one point to another. Okay, so for example, you want to turn on the lamp. Okay, how you want to turn on the lamp? Basically, you transfer energy from the source kepada lampu. Okay, transfer energy from one point to another. Okay, for example, if you use the socket outlet to turn on the lamp, so transfer energy from the socket outlet to the lamp. So that is a simple electrical system. Okay, so basic electrical system consists of 4 elements. Okay, basic electrical system consists of 4 elements, which are source. This one. This is the first element, which is the source. Second element is control. Third element is the load, and the fourth element is the transmission system. Okay, so you need to know the function for each elements. Okay, so what is the function of source? Stated here is the one that provide electrical energy to electrical system. Okay, so it could be in DC, it could be in AC. Okay, I'm sure many of you, most of you already know what is DC and AC. So DC is direct current, AC is alternating current. DC is arus terus, alternating current is arus ulang alik. Okay, so the difference between DC and AC adalah for DC arus terus, for AC arus ulang alik. Okay, so it can be obtained from battery, generator or socket outlet. So if your source is battery, so is battery is actually supplying a DC or AC? Battery supplies DC or AC current?
DC.
DC. Okay, so battery is a DC. Generator and socket outlet is AC. Okay, so you should able to differentiate between DC and AC. So DC, the direct current, for example, the battery, usually the voltage is smaller than the socket outlet. So for example, the battery may be supply around 5 volt. The socket outlet in Malaysia, it could supply previously is 240, now is 230 volt. Okay. So my question is, why do you think kenapa socket outlet is a 230 AC? Kenapa tak guna 230 DC? Siapa boleh jawab? Why we, for the socket outlet, why we use AC, 230 AC? Why not 230 DC? Ada yang boleh jawab? Tak ada. Student mechanical pun boleh jawab. Okay, so basically, so if you look at here, okay. Untuk digunakan dalam jangka masa panjang. Okay, so ada yang jawab untuk digunakan dalam jangka masa panjang. Okay, tak apa, saya akan explain. So basically, if kalau tengok kat sini, DC is direct current and the voltage here is fixed. If we use the direct current and the source is 230, okay, this is DC. If the source is 230 DC, the voltage is fixed at 230. Compared to 230. Compared to alternating current, boleh tengok kat sini, dia punya voltage ni is not constant at 230. Dia ada turun naik dia. Okay, so this one is much safer. compared to DC. Okay, so for example, if we contoh soket outlet, awak sentuh dengan tangan, okay, tangan yang basah, okay, so current boleh mengalir through air, okay, so awak boleh kena electrical shock, okay, but if since the socket outlet is AC, dia punya outcome tu tak begitu parah lah, sebab dia voltage tu tak fix at high voltage 230, dia ada turun naik. But if it's DC 230, so kemungkinan besar mungkin tak tak mungkin awak dah sangat bahayalah if you kena 230 DC. So that's why DC usually the voltage is small. For example, battery ni the voltage is only 5 volt. Okay. So okay, so for chapter 1, there will be one question for chapter 1 in final exam. So please expect that the question is not straightforward. It's not something that you have in this slide, but something that you need to think. The question is not straightforward and the answer is not straightforward, since maybe your final exam is online. Okay, so don't expect the question is straightforward. The questions may be something like this, where the question asks you to think why and give justification. Okay, so the next element is control. The next element is control. So the function of the control element is to control the flow of electrical energy. Okay, so the most simple control element is switch. Okay, ini yang paling basic. So switch permits the energy to flow or else interrupts the flow. Okay, so you know the symbol for switch. Macam ni. This is open, this is closed. Okay, so if the switch is open, the current cannot flow. If the switch is closed, then the current can flow. Okay, so this is how the switch actually control the flow of electrical energy. So if you want to turn on the lamp, you need to turn on the switch. If you want to turn off the lamp, you need to turn off the switch. So switch is the control element. Okay, the basic one. Tapi sekarang actually we have many other control elements yang more advanced. Okay, so sekarang kita ada lampu yang boleh automatic turn on, turn off. So that's one, it uses sensor. Okay, so sensor is another control element. And the third one is the load. Load, the functions to absorb the electrical energy and perform a given task, purpose or work. Okay, so load ni adalah load ni adalah elemen yang terakhir lah. Contohnya lampu, kipas. Okay, so dalam kipas ada motor. So the load is the motor. Okay, the ones that do the task or purpose or the work. And lastly, we have the transmission system. The transmission system is to conduct and transfer electrical energy from source to load. Okay, so example of transmission system is insulated wire lah. Okay, wire berpenebat. Okay, it is something that can conduct electricity. So when you understand this, you understand the concept of the electrical system and you understand the function of each element. So next time bila awak nampak satu contoh aircon, okay, so you can actually imagine how the air conditioner actually work. Okay, so the system should have source, it should have control, it should have the load, and it should have the transmission system. So this is example of basic electric system. So this is the torchlight, okay, lampu suluh. So this is the physical configuration of a torchlight. We have a battery, usually we have two batteries, AA batteries. And then we have a switch here to control on off. And we have menthol lamp. Okay. So if you convert this physical configuration, convert it to a circuit diagram, so you have something like this. So this is the symbol for battery. This is positive, this is negative. Okay, so this is positive, this is negative. And then it connect to the switch. This is the switch. And this is the load on the lamp. Okay. So how the system actually works? So if the switch is not on, okay, meaning it is open, the current cannot flow, so the lamp cannot turn on. But if the switch is closed, okay, now the current can flow, so the lamp here will turn on. Okay, so very simple example of electrical system. Next is the headlight system in cars. Okay, so you know that cars, you have two headlamps left and right. Two headlamps left and right. This is two headlamps. And also you have a battery in your car. And also you have the switch. Okay, switch is the one that you use to turn on and turn off the headlamp. So switch ni adalah switch yang ada dekat steering tu lah. Yang bila awak pulas, dia turn on and then turn off. Okay, so that is also a switch. Okay, and the transmission system here is the wires here. Okay. So if you convert this physical configuration to circuit diagram, you have something like this. So this is the voltage source. This is a 12 volt. Okay, this is a 12 volt. And then it is connected to the switch here. Okay, and then you have the this is the first headlamp, and this is the second headlamp. Okay, so this is the first headlamp, this is the second headlamp. Okay, why we use this resistor symbol? Okay, perintang punya symbol, because in load usually we'll have the internal load RL. So this is the RL, the internal load inside the headlamp. Okay, so you look at here, because some of you is from diploma, I'm sure that you know the difference between parallel connection and series connection. So this is parallel connection. We have another connection which is a series connection. So my question is, why in the headlight system we use a parallel connection? Why we don't use a series connection? Why we don't have a connection like this? This is headlamp 1, headlamp 2. This is headlamp 1. This is headlamp 2. Headlamp 2. So this is parallel connection. This is series. Why in this headlight system we use parallel? Why we don't connect it in series?
Sebab kalau satu mati, lagi satu takkan mati.
Okay. Okay, so very simple question So ini suppose majority boleh tahulah. Okay, beza between parallel and series. So if one headlamps have problems, the other headlamps can still turn on. But if you connect in series, if the H1 is have a problem, the H2 will also cannot turn on. Okay. Okay, so the previous subchapter is electrical system. So now we'll go to electrical circuit. Okay. So electrical circuit consists of circuit element. Okay, and the circuit element is this. So the circuit element is the voltage source, resistance, inductance, and also capacitance. Okay, so this is a symbol for resistor, inductor, and also capacitor. Okay, so the voltage source creates forces that cause charge to flow through the conductor and other circuit elements. So energy transferred between the circuit elements. So the function of voltage source this one here is create force. Create force that causes charge to flow. So apakah itu charge? So biasa we talk about voltage and current. Okay, when we have source, the current turn on, the current will flow. Tapi what is charge? Okay, so charge and current is basically a similar thing. Okay, flow of charge is the current. Okay, so what is charge? Then we go to subchapter 1.3. What is electrical charge? So electrical charge is also known as electricity. Okay. So this one is most of you know already in your maybe metric in your physics. Okay. So we know that the elementary physics that all matter, all materials is made of atoms, and each atoms consists of electrons, protons and neutrons. Okay. We have atoms consist of electrons, protons and also neutrons. Okay. And we have a nucleus is consists of proton and neutron, and also we have electrons at the outer layer here. Okay. So protons carries a positive charge. Protons carries a positive charge. Neutrons carry no charge. So the protons and neutrons join together to form the nucleus. Okay, this is the nucleus. And then we have electrons which carry a negative charge. So the presence of equal numbers of protons and electrons leaves an atom neutrally charged. So if the number of protons and electrons is the same, then it is neutrally charged. And stated here, some atoms hold their electrons loosely when force is applied, especially electrons that are located at valence shell, outermost shell. So what it means here, if force is applied, okay, the electrons will get loose. Okay, especially the electrons at the outermost shell, if force is applied. Okay, so then what happens is that these loose electrons can be transferred into another atoms. Okay, so dia boleh berpindah bila force is applied, electrons di luar outermost layer boleh pindah kepada, will get loose and pindah kepada atoms yang lain. Okay, so dia boleh pindah from one atom to another when force is applied. So when electron escapes from the atom, okay, so when one electron escape from the atom, so the atoms here has the positive, the protons is higher than electrons, so it becomes the positive ion. Okay, and the atoms that acquire the electrons, okay, this atom which acquire the electrons, okay, will becomes a negative ion because it has an excess of electrons. Okay, boleh faham So if you have any question, boleh just interrupt terus untuk tanya. So this I already explained. Materials that have excess of electrons is said to have negative charge, and materials with deficiency of electrons is said to have positive charge. Okay. So electrical charge is an electrical property of matter that exists because of an excess or defiance of electrons. And these are the unit for charge. Okay, the unit for charge is in coulomb. The symbol is C. So 1 coulomb is equals to 6.24 10 to the power of 18 electrons, and 1 electron is equals to 1.602 10 to the power of negative 19 coulomb. Okay, so this is fixed. And if you look at here, materials with charges of opposite polarity attract together, but materials with charges of same polarity will repel. Okay, so this is basic, the same apa, sama je macam magnet. Okay, the opposite polarity attract together, the same polarity will repel. So next is the electromotive force, EMF, versus potential difference. Okay, so what is the difference between EMF and also potential difference? Basically, it is the same thing. Both EMF and potential difference is voltage. Okay, it is both voltage. But if you look at here, EMF is the electrical potential difference provided by an energy source like a battery. So the important word here is potential difference provided by energy source like a battery. Okay, energy source. Ini word yang penting lah untuk EMF. For potential difference, is the potential difference between point A and point B. Okay, is calculated by subtracting the potential of A from potential B. So that is basically the main difference between EMF and also potential difference. Okay, so varying magnetic fields also can generate an EMF according to the Faraday's law. And although EMF is also a voltage and measured in volt, it's all about the generation of potential difference. Okay, same for this one, potential difference. It is also a voltage. In an electrical circuit, current flows from the higher potential to lower potential. So for this one, the things that important that you know is this. Okay, important differences between EMF and potential difference. Okay, so potential difference is used in all energy fields. It is used in electric, it is used in magnetic, it is used in gravitational, but EMF is only used in electric circuit. Okay, and EMF is the electrical potential difference generated by a source. Okay, EMF generated by a source. Next, we can measure potential difference between any 2 points, but EMF exists only between the 2 ends of a source. Okay, so yang ni pun penting. Potential difference, you can measure voltage at any points, any 2 points. EMF is that you can only measure the voltage between the 2 ends of a source. Okay. So sum of potential drops around the circuit is equal to total EMF according to Kirchhoff's second law. So this one you will, I will explain further in chapter 2. Okay, so chapter 2 will cover on the Kirchhoff law. So what it means here is that it's stated that the voltage across the terminals of a battery is less than the EMF when the battery supplies current. Okay, so what it means is that usually, for example, if you have a battery, okay, for example, if you have a battery 5 volt, the rating here is 5 volt, but actually the voltage that it supplies is not exactly 5 volt. It could be 4.95, it could be 4.98, okay, something like that. It will not supply exactly 5 volt. Okay. So this is the terminal voltage. So terminal voltage is the potential difference at the terminals of the circuit. Even if there is no load, still the terminal voltage will be less than the EMF. So the terminal voltage is given by the equation V minus EMF minus IR. So IR ni is actually the voltage of the internal resistor. Okay, because you know that V is equals to IR. So this is actually V. Okay, the voltage of the internal resistor. Okay, because in the source it has the internal resistor. That's why even though it said that it will supply 5 volt, but actually it will supply less than 5 volt because it minus the voltage of the internal resistance. Okay, faham ya? So if the internal resistance is 0, the terminal voltage will be equals to EMF. So tadi you have the equation terminal voltage equals to EMF minus IR. Okay. So if the internal resistor is 0, 0 multiplied with the current, this will become 0. So V is equals to EMF. But in reality, in real battery, there is an internal resistance R. So supposedly, your V terminal, you cannot get V equals to EMF. Okay. So next we go to voltage and current. What is voltage? What is current? Okay. So this is a simple electrical system. You have the source. This is the source. You have the control element, the switch. You have the load, and you have the transmission system, the wires. Okay. So when the switch is turned off, the lamp will not light up. Okay. But when the switch is turned on, okay, the lamp will turn on. So the battery provides voltage that will push current through the bulb when the switch is on. Okay, so battery provides the voltage that will push the current. So voltage here is defined as the energy required to move a unit charge through an element, and it is measured in volt. Okay, so it is very important. The energy required to move a unit charge, a single charge through an element. So this is called voltage. Okay, so it is a measurement of a potential difference between 2 points. Okay, you need to have 2 points in order to measure the voltage, because voltage is the potential difference. For example, you have the circuit here like this. This is point A, this is point B. Okay, so you can measure the potential difference between point A, point B, which is VAB. Okay, you need to have 2 points. So this one is the same like I explained. VAB is the voltage between point A and point B. Okay, between point A and point B. This is VAB. So it is the energy or work needed to move one unit charge from point A to point B. Okay. So the plus and minus signs, the voltage polarity or reference direction. Okay, so you have the plus minus sign. Okay, so voltage is defined as energy or work per unit charge. Okay, so the definition, the previous definition is energy per unit charge. So the formula is V equals to W divided by Q. W is the energy, Q is the charge. Okay, work per unit charge. So a voltage source is an energy source that provides electrical energy or voltage. So there are two types of voltage sources. I already explained this, the DC and AC. So DC voltage supply constant voltage. AC supply varying varying voltage that varies with time. Okay, so example of DC is battery, example of AC is generator and also socket outlet. So next is current. So stated here, the flow of electrical charge is the current. Okay, is measured in ampere. So when the question asks you what is current, current is actually the flow of electrical charge. So if you look at this figure here, you have a tank and you have a pipe here and you have a faucet. Okay, kepala pipe. Okay. So apabila the kepala pipe ni tutup, okay, the water cannot flow. Okay. So when the faucet is off, is there any flow? Okay, no. But when the faucet is on, bila awak buka kepala pipe, when the faucet is on, is there any flow? Yes. So this is the same concept as current. Okay. Contoh dekat sini, dia kata this is the battery. This is the source. Okay, and this is the wiring, this is the switch. So if the switch is turned off, current cannot flow. But if the switch is turned on, the current will flow. Okay, so same application as the current. So current in a circuit sama juga. If the switch is turned off, the current cannot flow. Okay, sebab the switch litar ni tak bersambung. Okay, open circuit. But when the switch is turned on, okay, dia akan jadi closed circuit. Closed circuit. Then the current can flow. Okay, so very simple. So voltage provide energy to electrons, allowing them to move through a circuit. Okay, voltage provide energy. So the movement of electrons is the current. Okay, so when the voltage provide energy to electrons, the electrons will move. So the movement of electrons is the current. So this result in the work being done. Okay, so ni relation antara voltage dan juga current. So if you look at this circuit here, consider the following. Negative charge move from negative terminal of battery towards the positive. So dia cakap kat sini, negative charge actually move from negative terminal, okay, actually move from negative to positive. Okay, this is electrons. This is negative charge. Negative charge move from negative to positive. Differ from the current. Current flow from the positive to the negative terminal. So this is current, I. Current flows from positive to negative. Okay. So flow of current in metallic conductor is due to movement of electrons. However, it is accepted that current is the net flow of positive charge. So you know that current is the flow of charge is the current. So it's actually related to each other. So there are two accepted convention for direction of electrical current. The first one we call as electron flow direction. Second one we call as conventional current direction. Okay, so the first one here, it based on the electron flow. So like I said before, electron flow from negative to positive. But for current, sekejap Okay. But for current flow from positive to negative. Yeah, current flow from positive to negative. Positive to negative. So dua-dua ni betul dan diguna pakai electron flow and also conventional current flow. Tapi for engineering, okay, kita lebih prefer untuk guna the conventional current flow. Okay, so take in mind sepanjang awak 4 tahun dan selepas awak bekerja nanti, okay, awak kena tahu yang current flow from positive to negative. So this is based on conventional current direction. Okay, but if you base on electron flow direction, then it's the negative to positive. So there is difference between engineering and science. Okay, so basically both conventional current flow and electron flow are used and both are correct. In general, the science discipline uses electron flow, whereas engineering disciplines like ours, we use conventional current. Okay, so since this is the engineering course, we will use conventional current, which we know that current flow from positive to negative. Okay, don't say that is flow from negative to positive. So current is the time rate of charge, okay, rate of charge measured in ampere, and the formula is I equals to Q divided by T. Q is the charge, T is time in second. Okay, so current is the flow of charge, that's why it is time rate of change of charge, the flow of charge. That's why it is respect to time. Same as voltage, we have direct current, we have alternating current. Direct current, the current is constant, but the alternating current, the current varies with time. Okay. Next is the system of units. Okay, so these are the SI units that will be used in engineering subjects. Okay. So the first one is charge, energy, we have power, voltage, current, resistance, induction, and inductor, and also capacitance. Okay, so these are the units and these are the symbols. Okay, so I think most of you already know the unit and also the symbols for resistor, inductor, capacitor, power, and so on. And also this one, the units, okay, and also the formula here. Okay, for example, volt is the energy of 1 joule that is consumed when electric charge of 1 coulomb flows in the circuit. So basically it is 1 volt equals to 1 joule divided by 1 coulomb. So basically it's hard for you to exactly remember the definition of this, but instead it's easier for us to remember the formula here. So what you can actually do from the formula, you can write the definition on your own based on the formula. Okay. And so this is the SI prefix. Ini pun saya rasa semua tahu. Okay, the prefix, for example, kilo, milli, micro. Okay, kilo is 10 to the power of 3, milli is 10 to the power of -3, and so on. Okay, but nowadays kita biasa for calculation we use calculator. Okay, so and calculator can actually convert this directly, so you don't need to convert manually. Okay, so kita tak perlulah nak hafal ni power of deci, power of -1, and so on. You can just use your calculator. Okay, but still you need to know this. Okay, so any question for part 1? Do you have any question for part 1? Okay, soalan. So there will be calculation in this topic, doctor, according to the formula V equals to EMF minus IR. Soalan calculation ada. Ada. Saya pun tak boleh nak cakap sebab soalan pun tak ada lagi. Tapi usually adalah. Okay, calculation. Calculation apa? Saya pun tak sure. Okay, cuma I think midterm tak ada soalan on LO1. Okay, soalan LO1 will be asked in final exam, one question. Okay, so kalau awak tengok chapter 1 ni is more on theoretical part. Okay, so basically kita takkan tanya sebab sekarang kan online kan. So kita takkan tanya definition macam tu. Don't expect soalan yang macam itulah definition yang ada dekat slide dan nak salin macam tu je. So expect that the question akan minta awak untuk fikir. Okay. So for example dia akan tanya kita bagi masalah, kita minta awak penyelesaian dari awak in words. Okay. And then justification. Justifikasi based on the slide in chapter 1 macam tu. Okay. Calculation pun maybe ada jugalah. Tapi kita tak akan tanya di luar daripada ni. Mungkin kita akan tanya macam mana bil elektrik. Okay, macam mana nak kira bil elektrik dan sebagainya. So bil elektrik sampai kat rumah awak macam tu je. Awak tengok harga je. Tapi awak tak tahu macam mana nak kira dia. Okay, so contohnya. Okay, ada soalan? Ada soalan lain? So kita habis awal for part 1 actually sejam. FKM hari tu saya habis sejam setengah for part 1. So saya ingat nak continue with part 2 atau nak sambung part 2 on Friday. Sambung hari ni kan?
Sambung hari ni.
Hari ni so tomorrow tak ada kelas lah. Okay, sambung. So nak rehat ke? Nak take 5 ke?
Boleh juga.
Okay. So 5 minit. Kita rehat 5 minit. So sekarang 11:08. So kita start pada 11:13. Okay, so ada soalan tanya, is there any example question regarding this topic? Soalan. Soalan calculation ke? Sebab lambat lagi kan untuk final exam. So kalau ada soalan nanti saya akan share lah. Sebab masa sekarang belum ada contoh soalan. Cuma salah satu tanya is the electricity bill lah. Ya, macam mana kira electricity bill tu. Okay. Chapter. Okay, so sementara kita tunggu. Kalau ada soalan boleh tanya lagi lah. banyak yang daripada diploma UTEM tak? Saya tahu ada beberapa yang dari diploma UTEM yang saya melawat LI hari tu.
Saya diploma UTEM.
Sebab ada nama-nama yang familiar jugalah. So diploma UTEM rasanya dah expert kot untuk subjek ni. Saya haraplah.
Adalah. Kena refresh balik
Okay, sebab dia lebih kurang sama, cuma ada penambahan jugalah sikit.
Betul.
Okay, tutorial ada deadline ke? Deadline dia seminggu lah. Seminggu. So, contoh habis minggu ni, kan dah habis chapter 1. So, dah boleh buat lah tutorial tu seminggu. Seminggu, 2 minggu dah cukup dah. Okay. So, kalau tengok tutorial untuk chapter 1 pun, dia tutorial chapter 1 teori. So, I don't think we need to discuss on that. Tapi saya nak awak buat dan awak submit. Nanti saya akan share saya akan share jawapan. Okay. Dan soalan dia pun saya tengok yang ada di slide lah. So, I think tutorial 1 we don't need to discuss. Okay. Okay, dah 11.13. So, saya rasa saya nak continue terus. So, saya tak nak awak guna banyak data lah untuk ni. Okay, so chapter 1 part 2 pun saya dah share pada awak. Yeah. Okay, so we'll continue with chapter 1 part 2. So in part 1 we have learned on voltage, we have learned on current, charges, resistor, okay, electrical system, electrical circuit. Okay, so the continuation from chapter part 1 is that how we can actually measure those parameter, the voltage, the current, the resistor. Ini yang the basic ones lah. Okay, so I think most of you, okay, so ada soalan summary selalunya kena buat hari apa? Summary last hari Jumaat lah. Summary untuk minggu tu so hari Jumaat. Okay, so for example, for voltage we can measure using voltmeter. Current we can measure using ammeter. Resistor we can measure using ohmmeter. Okay, ni semua saya rasa semua orang pun tahu. Okay, but we also have what we call as multimeter. So this multimeter can measure voltage, we can measure current, can measure resistor and so on. Okay, so this is example of digital multimeter and analog multimeter. Okay, this is digital multimeter, this is analog multimeter. Okay, so if you look at here, boleh nampak kat sini, if you want to measure voltage, you need to make a connection here. If you want to measure current, you need to make a connection here. Okay, so I think all of you know what is the difference between digital and analog. So digital, the value here is shown in digits. Analog, the value is shown dalam bentuk scale. Okay. So this is the meter indication. Digital, digit, okay, 3.5. Analog dalam scale. So the connection for the multimeter, you need to make correct connection, positive, positive, negative, negative. So, okay, so previously I said that you can use multimeter or ammeter to measure current. Okay, for example, you have the circuit. For example, you have the circuit, you have the battery source, you have the battery source, and then you have the resistor. Okay, so how do you measure the current? So the current here, current flow from positive to negative. Okay, so this is the current, and you want to measure the current. Okay, so to measure the current, awak kena buka circuit ni. Okay, potong circuit ni, buka, and then you connect it with an ammeter or multimeter. Okay, buka and then sambung kepada ammeter or multimeter. So the connection must be in series. Okay, connection must be in series. So most analog ammeter have a number of possible setting. Okay, maximum possible current that it can measure. For example, maybe the maximum current is 2 ampere, 200 milliamp, 20 milliamp, and also 2 milliamp. Okay, so if you use multimeter, you must make sure that you put the setting to the highest possible rating. Start with the highest possible rating. So for example, if your multimeter, the highest possible rating is 2 ampere. Okay, awak ada circuit ni tadi. Okay, awak nak measure current. Sini. Okay. Ammeter ni, the first try, because you don't know the value of the current. Okay. So you must make sure that the setting you put to the highest possible rating. Okay. For example, 2 amp. So if the meter reading is too small, for example, this is your analog multimeter. This is the scale. For example, the scale is too small. Okay, kat sini. Then only you can change to the second highest rating, 200 milliamp. Okay, and so on. So barulah awak dapat value yang accurate, value yang sesuai. So for example, if the current is about 75 milliamp, then the ammeter will be set to 200 milliamp. Okay, yang paling sesuai. Because if the rating is too high, padahal if you set to 2 ampere, tapi sebenarnya the current that you measure is 1 milliamp. So the scale tu awak nampak kecil je, tak nampak sangat. Okay, so awak kena tukar kepada 2 milliamp punya rating. Baru awak nampak dia punya scale tu. Okay, so the important thing is safety, start with the highest possible rating. Kenapa? Why we need to start with the highest possible rating? Because if we start dengan rating yang rendah, for example, you start with 2 milliamp, tapi sebenarnya the current in the circuit is 20 milliamp. So what happen is that dia dah berlaku overload. Okay, overload pada meter tu. So ini akan menyebabkan kerosakan. It will most likely open its internal fuse. Okay, dia akan menyebabkan kerosakan. So that's why multimeter, ammeter di lab senang sangat rosak. Ammeter dan multimeter di laboratory senang rosak because students start using dengan the lowest rating. So berlaku overload pada multimeter tersebut. Okay. So the thing is bila dia dah problem, so we need to change the fuse lah. Multimeter fuse. Next, how we can measure voltage. Okay. So tadi for current, we measure in, the connection is in series. Okay. Okay. Okay, so the previous one, to measure current, we need to connect the multimeter in series. But for voltage, you need to connect it in parallel. Nampak? They connect parallel. So, you want, for example, this is point A, this is point B. You want to measure the potential difference or the voltage between point A, point B, which is the VAB. So you need to connect the multimeter in parallel to the circuit. Okay, in parallel. Okay, and the polarity also, you must make sure that the polarity is correct. Positive, positive, negative, negative. Same for the current. Positive, positive, negative, negative. Okay, so make sure the polarity is correct. And lastly, how we can measure resistance. So multimeter can also be used to measure a resistor. Okay, so to measure a resistor, first you must take out the resistor from the circuit. Buka resistor from the circuit. You cannot measure resistor when the resistor is connected to the circuit. Okay. So in manually, you can actually know the value for the resistor kalau using the color code for resistor. But nowadays, you don't need the color code. You can just use the multimeter. Okay, take out the resistor and then measure from this point to this point. Okay, so for a resistor, you don't have the polarity, positive and negative. So you sambung Sini positif, negatif boleh, positif, negatif pun boleh. This is for resistor. Okay. And so when we measure the voltage, the current, the resistor and so on, we will deals with several parameter, okay, which is error, accuracy and precision. So you know that error is the difference between the true value and the measured value. Okay, so for example, the true value is 5 volt. However, the ones that you measured is 4.98. So the difference between the true value and the measured value is the error. Okay. And accuracy is the degree to which a measured value represents the true or accepted of a quantity. Okay, a measurement is said to be accurate if the error is small. So error and accuracy has a relation to each other. So if the error is high, accuracy is low. If the error is low, accuracy is high. Okay. And lastly, we have precision. So precision is the repeatability or consistency of a measurement. Okay. So for example, if you measure the voltage, so the first try you get 5 volt. Second try you get 5 volt. Third try you get 4.99 volt. Okay. So this means that it has a high precision. Compared to if for example the first try you measure 5 volt, second try you measure 3.5 volt, third try you measure 4.1 volt. Okay, so if you compare this and this one has a high precision compared to this one. Okay, the repeatability or consistency of a measurement. And lastly is the resolution. So resolution is the smallest increment of quantity that the meter can measure. So the smaller the increment, the better the resolution. Okay, so we have 3 multimeter here. Okay, so which one has the highest resolution? Can anyone answer which one has the highest resolution? Kau malu nak cakap, boleh tinggalkan jawapan di chat. Which multimeter has the highest resolution? First, okay. Yang second? First and second. First and second both have the same resolution. Okay, so if you look at here, the first multimeter has the better resolution compared to the third multimeter. Okay, because the first multimeter can measure the smallest increment is 0.001. This one, the smallest increment is 0.001. But multimeter 1 and multimeter 2 has the same resolution because the increment is both 0.001. Okay. So next is symbols of electrical source and components. We have, so these are the component symbols. Symbols for the components that we usually use in electrical engineering. So the first one is the symbol for switch. The function is to connect and disconnect the current. And then we have earth ground. Okay, so earth ground is for protection. Chassis ground. When we talk about ground, it has the same function, but usually we will use earth ground. Okay, so chassis ground is used for shielding and grounding to prevent electrical shock. Okay, both ground is used for grounding to prevent electrical shock. And then this is the symbol for resistor, and this is the symbol for variable resistor. Okay, so resistor, the value is fixed. Variable resistor, you can vary the value for the resistor. And then we have capacitor, battery, symbol for battery. This is the symbol for AC voltage source, and this is the symbol for diode. Okay, so we will learn in detail on diodes and capacitor in next chapter. Okay, kita akan baca lebih detail on capacitor and diode pada chapter seterusnya. So setakat ni kita hanya concentrate pada resistor lah. Okay, paling basic. Okay, circuit elements. So tadi previous in part 1 we already learn on the circuit elements, where we know that we have example of circuit element is the source, resistor, inductor, capacitor. Okay, so elements is a basic building block of a circuit or electrical components of an electrical circuit. So electrical circuit is the interconnection of these electrical elements. Okay, while circuit analysis is process of determining voltage across or the current through the elements of the circuit. So that is the circuit analysis. Okay, so when we talk about circuit elements, okay, we can divide it into two. So first one is active element, the second one is passive element. So what is the difference between active and passive? Okay, so first let's look at the passive component. So it is the components that do not supply voltage or current. Okay, for example, resistor, capacitor, inductor, transformer. It cannot supply current. It needs another source to supply the current. So this one we call as passive components. Active components is the components that have their own power source. They can generate their own power. Okay, they don't need other source to generate power. Example is voltage and current source, battery, generator, fuel cell, transistor, and also integrated circuit or IC. So all of this can generate its own power source. Okay, so that is the difference between passive and also active. Okay, so this is the same. Active, capable of generating electrical energy. Passive, not capable of generating electrical energy. Okay, and both voltage and current deliver power to the electrical circuits. Okay, voltage and current source. Okay, so these sources, okay, voltage and current source, we can also divide it into independent source and also dependent source. Okay, so what is independent source? What is dependent source? Independent source, dia independent. Dia tak bergantung kepada parameter lain. Okay, so stay kat sini. It is an active element that provide a specific voltage or current that is completely independent of other circuit element. Okay, the source independent. Dia tak bergantung kepada elemen-elemen lain. Okay, so for example, figure 1.11. So this is the symbol for voltage source. Okay, so voltage source, this one symbol begini, positive negative ni, we can use for DC and AC. Okay, but for this one, this is only for DC because this is the symbol for battery. So battery is DC. Okay, and you look at here, the symbol here is V. Okay, V. So it is not dependent on other elements. Later I will show you the difference with the dependent source. This one is the independent source, current source. Okay, so the symbol is like this. Okay, you have the arrow. The arrow actually shows the flow of the current. Okay, macam ni, direction of the current. Okay. So ideal independent voltage source delivers the circuit whatever current is necessary to maintain its terminal voltage. So when the independent source said that is generate 5 volt, then the voltage that it keluarkan is 5 volt. Okay, dia tak bergantung kepada mana-mana elemen lain. Okay. So same for the current source lah. Okay. So now dependent source dia bergantung kepada elemen-elemen lain. So it is an active element in which the source quantity is controlled by another voltage or current. So we have several types of independent source. We have voltage controlled voltage source, we have current controlled voltage source, voltage controlled current source, and also current controlled current source. Okay, so if you look at here, this is the symbol for dependent voltage source. This is the symbol for the dependent current source. Similar to the independent, but the difference is the shape. Okay, independent voltage source, the shape is round. Dependent source, the voltage is macam ni, diamond. Okay, so if you have a source diamond macam ni, so you know that is a dependent source. Okay, so if you look at this circuit, okay, so this is a independent source, but this one is a dependent source. Okay, this is actually a voltage, but it depends on the current. So that's why the value here is stated that it is 10I. I is the current, and this is actually the current controlled voltage source. Why current controlled voltage source? Because you know that this is the symbol for the voltage source. Okay, so this is the voltage source, but it depends on the current. Okay, because the value here is 10I. So basically the value of the voltage is 10 multiplied with I here. It depends on the current. So this is the current controlled voltage source which depends on the I or the current, and the value is 10I volt. Okay. So saya harap awak boleh bezalah what is the difference between independent source and also dependent source. Okay. So that's all for part 2, chapter 1, part 2. So any question? Any questions?
Doktor,
Ya.
untuk summary tu kena tulis dalam point ke atau buat perenggan?
Tak kisah.
Bisa, okay.
Okay, any other questions before we end the lecture? Okay, so lepas ni dah boleh buat tutorial lah, tutorial 1, and then upload it inside the Ulearn. Questions of topic 2 straightforward or just like topic 1? Just like topic 1. Topic 2, topic 1 ni maksud awak part 1, part 2 kan? So sama je. Chapter 1, the question is not straightforward. Okay. Maybe ada calculation but sikit lah, tak sebanyak chapter-chapter lain. Okay. Okay. So kalau tak ada soalan, kita akan sambung semula next week. So esok tak ada ya. Esok tak ada sebab kita dah habis chapter 1. Untuk awak, saya awal compare dengan FKM. FKM hari tu tak masuk part 2. Okay, so
Doktor, last question. Kalau untuk tutorial tu, boleh buat dalam Word tak? Sebab kebanyakan semua teori.
boleh?
Boleh? Okay.
Boleh.
Thank you.
Tapi jangan copy
Tak.
jangan copy
Tulis sendiri.
Okay. Okay, so I think we can continue next week on Thursday 10 AM for chapter 2. So saya belum upload lagi slide for chapter 2. Maybe today saya still edit lagi. So today I will upload the slide for chapter 2 for week 2. Okay. So terima kasih.
Thanks, Doktor.
Thank you.
Thank you, Doktor.
Sama.